In this video, we will be discussing proportionality. So we define proportionality as the relationship between two quantities or variables. When one quantity or variable is altered, the other is also altered by a consistent amount. Take a look at this example. If the amount of pressure is increased, the volume of the object decreases. In this example, the first quantity is the amount of pressure and the second quantity is the volume of the object. Increasing the pressure causes a decrease in the volume of the object, while decreasing the pressure leads to an increase in the volume of the object. So now let's begin solving question number 1 from exercise 1b. The statement of the question is, if x is directly proportional to y cube and x equals 32 when y equals 2. Find an equation connecting x and y. Find the value of x when y equals 6. Calculate the value of y when x equals 8 and draw the graph of x against y. Now, first part from this question, according to the statement, since x is directly proportional to y cube, so we write this statement as x equals ky cube, where k is a constant. Now let me explain the constant k. In mathematics, we use the constant of proportionality to calculate the rate of change and at the same time determine if we are dealing with direct variation or inverse variation. Let's assume that the cost of 5 books is $1,000. The cost of 5 books is $100. We determine that the cost of one book is $20. Therefore, we have found that the constant of proportionality for the cost of a book is $20. So now, when y equals 2 and x equals 32, as given in the statement of the question, with the help of x and y, we can find the value for this constant k. So I will substitute x and y equals 32 and 2 in this equation. So this equation becomes 32 equals k multiplied by 2 raised to the power 3, because we have y raised to the power 3. Now 32 equals k times 2 raised to the power 3 is equal to 8. And to find k, this equation can be written as 32 upon 8 equals k. Since 32 is divisible by 8 and 8 times 4 equals 32, so the value of k is 4. So therefore, an equation which connecting x and y is x equals 4y. Actually, this is the equation where k is 4. So this equation becomes x equals ky cube as x equals 4y. Sorry, let me correct this equation. 4y cube. So this is the required equation connecting variables x and y. Now second part from the question is to find the value of x when variable y equals 6. So I'm going to use this equation again, x equals ky cube, and I will substitute y equals 6, which is given in the statement of the question, and k equals 4, which we have found. So this equation x equals ky cube becomes x equals 4, which is the value of k, and multiplied by 6, which is the value of y, since we have y cube. So now by substituting y equals k 6 in this equation becomes x equals 4 multiplied by 6 raised to the power 3. Now 6 raised to the power 3 equals 6 multiplied by 6 multiplied by 6. The total product is 216. Now x equals 4 multiplied by 216. Now 216 times 4 equals 864. So x equals 864 when y equals 6. Third part from this question is to calculate the value of y when x equals 8. So again, this is the equation x equals k y cube, and I'm going to put x equals 8 in this equation, and the value of k which we have found, k equals 4. So this equation becomes 108 equals 4 multiplied by y cube, because the equation was x equals ky cube. So putting x equals 108 and k equals 4, this equation becomes 108 equals 4 multiplied by y raised to the power 3. Since we are finding the value of y, so I will take this 4 from right to the left side, so this equation becomes y cube equals 108 upon 4. This 108 is divisible by 4, so we say that 4 times 27 equals 108, which means y cube equals 27. We are finding y. To eliminate cube, I will take cube root of the both sides. Taking cube root, equation becomes y cube root of y cube equals cube root of 27. Now 27 is a perfect cube number, so we can write it as 3 multiplied by 3 multiplied by 3, or in exponential form 3 raised to the power 3. So y equals 3 because cube root of y cube, cube root of y is equal to 3, because 27 is a perfect cube number. So now last part from this question is to draw the graph of x against y. Okay, now in order to plot the graph of the equation x equals 4y cube, we must select various values for the variable x as input, which will yield corresponding values for the variable y. However, for simplicity, I will only consider 2 values for x, resulting in 2 corresponding values for y. This decision is made due to the significant disparity between the values of x and y, necessitating a larger graph paper. So I will take only 2 values for x and y. Now, when y equals 0, putting this value of y in this equation x equals 4y cube, the whole equation becomes x equals 0 multiplied by 4, which is equal to 0. So if y equals 0, then the output x is also equal to 0. Now if I take y equals 2, keep in mind you can also take y equals 1 to find the value of x for y equals 1. But I will take y equals 2, so by putting this y equals 2 in equation x equals 4y cube, we get 2 times 2 times 2, 8, 8 times 4, 32. So x is equal to 32. Now let's plot these 2 ordered pairs, or the values of x and y, on this graph paper. We have 2 axes, horizontal axis and vertical axis. On horizontal axis I am going to take the values of y, and on vertical axis I'll be taking the values for x. So a suitable scale, let's talk about suitable scale. I will take 2 large squares for 1 unit on y-axis, which means that these 2 next large squares will show next 2 units on y-axis, and on x-axis I will take 1 large square as 8 units on this vertical axis. So second large square will represent 16 units, third large square will show 24 units, fourth large square 32, and fifth large square will show 40 units. Now to plot these ordered pair where x is 0 and y is 0, so our first point of intersection is 0, 0 at this point. So I will mark a red cross at this point where x and y both are 0. Now second ordered pair, y equals 2 units and x equals 32 units. Let's find the point of intersection between these 2 ordered pairs. So here y is 2 units and x is 32 units. So the point of intersection between these 2 ordered pairs, or between these 2 values of x and y is 32 and 2, which means that 2 units for y-axis and 32 units for x-axis. So this is the graph. A straight line is obtained when we plot these two values of x and y, or the ordered pairs x and y, on this sheet of graph paper. Now that's it with question number 1. Now question number 2 is, if z square is directly proportional to w and z equals 4 when w equals 8. Now find an equation connecting w and z. Find the value of z when w equals 18. Calculate the value of w when z equals 5. And finally we will draw the graph of z square against w. Now first part from the question is to calculate an equation or find an equation connecting w and z. Okay, according to the statement, since z square is directly proportional to w, so this statement can be written as z square equals kw. We know that k is a constant, so let's find the value of this k when we substitute z equals 4 and w equals 8 in this equation. So z square becomes 4 square equals k multiplied by w becomes k into 8, because w is equal to 8. Now to find k, first I will take the square of 4, which is 16, and then I will take this 8 from right to the left side, so this equation becomes 16 upon 8, and we know that 8 times 2 equals 16, so k equals 2. So this is the value of k when z equals 4 and w equals 8. So therefore the required equation connecting w and z is z square equals kw. I will just replace this k by 2. Second part from the question is to find the value of z when w is equal to 18. So again, this equation z square is equal to kw. This equation becomes z square is equal to 2, w is 18, so z square equals 18 times 2, 36, and 36 is a perfect square number because I am going to take square root of the both sides to eliminate the square from z. So square root of z square is equal to the square root of 6 square. So taking square root, z equals positive negative 6, which is the required value of z when w is equal to 18. Now third part from the question is to find the value of w when z is given with 5. So again the same equation which was z square equals kw, but here z is given which is 5, so this equation becomes 5 square equals 2w. 5 square is equal to 25, and 25 upon 2 equals 12.5, which is the value of w when z is equal to 5. Now last part from this question is to plot the graph of z square against w. Now we need some inputs and outputs for w and z. So if I take w equals 0, and if we put the value of w in this equation, then z square equals 2 multiplied by 0 gives us 0. So z square is also 0 if w is 0. And if we take w equals 1, then 2 multiplied by 1, z square equals 2. And if we take w equals 2, then z square equals 2 multiplied by 2, 4. And when we take w equals 3, then z square becomes 2 multiplied by 3, 6. Now let's draw these values of w and z square on a sheet of graph paper. So here we have two axes, the horizontal axis w and the vertical axis z square. So I will place the values of w on horizontal axis, taking one large square as 1 unit, 2 large squares 2 units, 3 large squares 3 units, and 4 large squares 4 units. Same as on y-axis on z square, or on this vertical axis I will take 1 unit as 1 large square, 2 units 2 large squares 3 units, 3 large squares 4 units, 5 units, and 6 units equals to 6 large square. Now the first ordered pair is W0 and Z square equals 0. So we get the point of intersection at this point where both W and Z square are 0. Second order pair, when W equals 1 and Z square equals 2, so I will take 1 unit from W and 2 units from Z square, and the point of intersection between these two uh, numbers is 1 and 2. So I will place a cross sign at this point where we have the point of intersection between these two numbers. Now third order pair, when W equals 2 and Z square is 4, so the point of intersection between these two elements of the ordered pair is 2 and 4. First I will write the horizontal axis and then the vertical axis Z square, which is 4. And the third order pair where W is equal to 3, actually this is for the fourth ordered pair, and Z square is 6, so this is the point of intersection between W and Z square with the ordered pair 3 and 6. And if we join these point of intersections, we get a straight line. So the graph for Z square is equal to W is a straight line. Now question number 3 from this exercise is, it is given that y is directly proportional to x raised to the power n. Write down the value of n when ym square is the area of a square of length x meters, and y cubic centimeter or y centimeter cube is the volume of a cube of length x centimeter. Since y is directly proportional to x raised to the power n, then y is equal to kxn. Now where k is a constant, here ym square is the area of a square of length x meters. So we know that area of a square is equal to its length multiplied by length. The product of any two dimensions of a square is equal to the total area of the square. Since area is given in this first part of the question, which is ym square, so ym square or ym square is equal to length of the square is x meter, and this is also given in the statement of the question. So length multiplied by length means x meter multiplied by x meter. So by taking the product of xm multiplied by xm, the product is x square square meter. And on the left side, the area of the square is y square meter or ym square. So we get y is equal to x square. So if we substitute this y is equal to x square in this equation, where y is equal to kxn, so this equation becomes x square is equal to kxn. So we are finding n, so n is equal to 2. Now second part from the question is, since y is directly proportional to xn, again y is equal to kxn, where k is a constant. And since y cubic centimeter or ycm cube is the volume of the cube whose length is x centimeter, now let me define this geometrical shape cube, a closed geometrical shape having 6 square shaped faces. So volume of the cube is the product of all 3 dimensions, length multiplied by length multiplied by length. In case of cuboid, we will be finding the volume of cuboid as length multiplied by breadth multiplied by height. So therefore y cubic centimeter or y centimeter cube, which is the volume of the cube given in the statement of the question, is equal to its length multiplied by length multiplied by length. Since length of the cube is x centimeter, so this equation becomes x centimeter multiplied by the second length x centimeter multiplied by the third length x centimeter. So the total product is x cube cubic centimeter. So y is equal to x cube. So if we substitute the value of y in this equation where y is equal to kxn, so this equation becomes x cube is equal to kxn. Since we are finding the value of n, so on both sides we have the same base xx, so n is equal to 3, which is the required value of n.